Hello everyone, let's look at the following problem. So what do we have here? We have gravitational acceleration towards the ground equals to 10 meters per second squared. We have two objects, A and B. They have the same initial velocity of 20 meters per second. However, also they have the same position, but object A begins its journey first, and after 1 second, object B will join the journey. Okay, so it means that if object A will travel t time, that means that object B will travel t minus 1 time. And of course, when we're going to use a formulas, let's say for position, instead of t, we will use t minus 1 for object B. Okay, so what are the questions? So we need to find when and where those objects have the same position. Okay, to answer this, we will create a function of position for both objects A and B. We're going to use this formula, x0 plus v0 times t, initial velocity, initial position, plus acceleration divided by 2 times t squared. Okay, for both objects, we're going to use this formula. However, again, because we know that object B start to travel 1 second after object A, we will use t minus 1 instead of t in this formula. Okay, so object A, initial position 0, initial velocity plus 20, because this vector is at the same position direction as y-axis, minus 10, which is gravitational acceleration, divided by 2 times t squared. Minus, again, because the direction of acceleration is in the opposite direction than y-axis. That is y is minus. So finally we have this expression for position function of position of object A. Okay, now we're gonna build function of position for object B. Initial position also 0, initial velocity also 20, but again t is minus 1. Okay, also minus 10 divided by 2, okay, times t minus 1 squared. So this is expression for position for object B. Now, we are asking when and where they will have the same position, which we need to say that x of A equals to x of B. Okay, that's why they have the same position. That's what we are actually want to find. Okay, so x of A equals to this expression, x of B equals this expression, and now we can open the brackets here, for example, and we see that we can cancel out 20 times t from the left and the right. Okay, from the left we have minus 5 times t squared, but when we open those brackets, we can see that we also can cancel out this expression of minus 5 times t squared from the left and from the right of the equality. And finally, we can say that this expression will give us the time that will take for object B, no, object A, okay, because we calculated t, not t minus 1. Okay, this is time that will take for object A, the first object, okay, and he will see that object B have the same position as he is, the object A. But if someone asks you, okay, so what time object B traveled, it will be TB equals 2.5 minus 1, which equals to 1.5 seconds. Okay. Now where we can use expression of the position of A or B. This is much easier to use, okay, and we will substitute t by 2.5 seconds, and we will find the same position for both objects. Okay, again, we are using this expression. We will substitute t by 2.5 seconds, and initially, I hope there are no mistakes. Initially, we have that the position that they will have when they will pass each other is 18.75 meters. Okay, also we can ask what are the velocity of both objects. Let's say VA equals initial velocity of A plus g times t. Okay, so VA equals to 20 minus 10 times t. Okay, and the velocity would be 20 minus 10 times 2.5. 20 minus 25 equals minus 5 meters per second. Okay, which means the direction of object A is towards the ground, okay? It's after he reached the maximum point. Let's see about B. VB equals to initial velocity, which also 20 minus 10 times again t minus 1. Okay, so 20 minus 10 times 1.5 equals to 20 minus 15 equals to 5 meters per second, which means even though they have the same position, but they have different velocities. This is still going up. It didn't reach the maximum point yet. So that's it. We'll see you at the next problems. Thank you very much.